The correct mechanism for a given overall reaction has to both add to the correct overall reaction and have a slow step that predicts the rate law. This slow step is also called the rate limiting step. Typically, some part happens really quickly and then other parts happen really slowly. And the rate of the overall reaction seems to depend on how long the slowest component takes. Um, a typical type of problem would be given the following reaction, determine the overall reaction, write the rate law, identify any intermediates, and identify any catalysts. We've talked about how to do A and C and D. We need to now learn about B. Okay, so I've already written out the mechanism here, so you can pause and take a second to write it down. And now in determining the overall, I'm going to cancel out anything that cancels. It looks like here, that's the only thing that cancels. So if I were to write my overall reaction, two NOs plus an O2 forms two NO2. Now, in writing the rate law, we need to look at the slow step. How do you know which step is the slow step? You were told which step is the slow step. And specifically, we're going to look at the slow step's reactants. Writing my rate law, it's going to be rate equals K something. Now that something is going to be these two things. I have NO, so it's going to depend on its concentration. How many NOs are there? There are two of them, so it'll be NO squared. C, identify any intermediates. N2O2 is an intermediate. D, identify any catalysts. For this reaction, there were no catalysts. Now there is one for you to try.